We will be just showing you one real use case where we use the low-end devices in a real world, just a small talk. So basically, one of our customers, they were using IP camera in an industrial environment. And so how we supported them in optimizing their system and how they started using DPDK, we will be just showing you in a small presentation. So we will first tell you about the problem statement, and then what is the solution we propose them. So DPDK on the i.MX platform, part of it is already available into the dpdk.org. At least the eNet FEC and eNetC platform PMDs are supported. The QoS support is scheduled to be sent patches this month. So the platform support is now more or less available as part of the DPDK. The customer's problem was he was using an IP camera. Our i.MX devices has an inbuilt ISP, ISI kind of interface for connecting directly to the specific cameras. And where the kernel-based driver, they capture using a MIPI and CSI directly to the memory. And once the frame data is available, the application picks up the frame data, it processes them, packetizes them, it does some specific processing, and then it uses the socket interface to send the packet out to the network. What that means to us in terms of processing? When we look from a DPDK style of way, we are doing 2 times packet copy. One, when the frame data is available into the memory, there we are copying it to the user space. Secondly, when the packets are ready, we are using socket interface to again copy them from user space to kernel space and sending them out. So we realize that that's a very easy way for us to, at least we can optimize at least this part. So when we started looking into this one, we realized that we can very well write a special PMD for this ISP ISI interface where we can directly memory map the whole memory, and we can packetize and we can make those frames available to the DPDK. And then we already have for these devices, we already have the DPDK PMD available, so we can very well use that for sending those packets out. So while working on this, we started looking into developing this ISI image capture PMD. We realized that there are few shortcomings. The memory was earlier contiguous. We need to create space for adding some of the metadata for the RT MBUF. And then we can always use the RT indirect API approach. So finally, we earlier we were having the whole frame data, but now we started doing the line-by-line processing instead of frame-by-frame processing, so that we can build a clear pipeline and we can reduce the overall latency of the system. So this is just a demonstration of the system where we were able to achieve it. So the IP camera was picking up the packets and then using a TSN switch, the packets were going to another ATEM plus, which is doing intelligence processing on the image data, which is capturing, and then it's feeding that data into a IMX RT, which is feeding into a servo motor. So that way, combining the DPDK and then image processing, we were able to help customer with the building this use case. So in summary, we added the DPDK access for the hardware ISI frames, and we added a sample application for encoding the video stream into RTP or RFC 4175 Ethernet frames. We modified the driver to create some headroom for each line of the video frame. We created a pipeline in the application, and we finally achieved the 0 copy. So effectively, I'm not giving here the actual numbers, but we were able to bring down the processing in less than 1 core for the customer. And earlier, the application was waiting for the whole frame data. That is, after 30 milliseconds, it was getting any of the data. But now we are working on line by line. So every 35 microseconds, we are giving the data to the application, and then it's sending them out. So overall, from end-to-end point of view, there is a good reduction in the latency.
Yes, so maybe a quick one. So when you said line-by-line image, so are you having a buffer or MBUF for each of the line, or you just compact the lines into a large buffer?
So basically, earlier, see, ultimately camera is capturing line by line only. But the driver, the way it was built, it was sending the whole frame data. Now the line by line, based on the size of the line, what kind of resolution we are dealing with, we are converting into a RTP frames, and based on the algorithm which customer is using, if they are using raw, it's going out as it is. But if they are applying any particular video algorithms, the packet are getting converted into that, and based on the size of the packet, single packet or fragmented packets are going. But ultimately the end side, they know the frame and the line details, so they are consolidating the frame again.
Oh, it's at the end. Okay, thanks.